So that means we got to go through the process again, write this equation again. But this time we can plug in, instead of using c, we can plug in a -1 here. So I'm going to keep the negative factored out. So negative 4x squared plus x plus 40 equals, we know our a is a -4, so we want to plug in our -4, x squared plus 9 plus bx plus c, and we know that c is a -1, times x plus 4. Now what we want to do is see if there's a, we can't, I'd love to get rid of this term here, but because this x is squared, if I let this be a -3, that's going to turn into a +9, and that's going to turn this into an 18. There's no number I can use to get rid of this term. I don't want to get rid of this term because if I do, it would get rid of the bx. But actually, I'm going to show you a trick. Now, what you have to do, what the trick is there's a way that you can figure out what your terms are, but you have to have everything in expanded polynomial form. What that means is no parentheses, no factored out, no GCFs. So I'm going to have to FOIL this. I'm going to have to distribute the -4 here and distribute this negative. What you want is you want both sides to look like the same style. So if we distribute this negative, it's a -4x squared minus x minus 40 equals, distribute this -4 to both terms, minus 4x squared minus 36. Now we have to FOIL this, so that's a bx times x, so that's a plus bx squared. That's a bx times 4 plus 4bx, a -1 times x minus x. Now do keep in mind bx and x are not like terms, so they cannot add or subtract. -1 times a +4 is a -4. Now what we want to do here is just see if we have any like terms. And we definitely want it to write it the same, x squared, x in number, and then anything else. So let's see, we only have 1x squared, so we're good here. The -36 and the -4 definitely go together. Those are like terms. Let's see. Oh wait, -4x squared plus bx squared. Actually, you want your x squareds together. Now we can combine them. So this is what we'll do. Let's do 1 for the x squareds. We'll just say kind of like ... And let's see, we have, okay, so we're good. I'm just going to cross those out. Then we have, we'll do the x's next. So we have a 4bx and a minus x. So we have a 4bx minus x. Do an arrow. I don't really want to say equals. And then in terms of just numbers, we've got a -36 and a -4. Well, that's a -40. Now I want you to see something. The x squared on this side should equal the x squared on this side. The x on this side should equal the x on this side. And you notice something? The -40 on this side equals the -40 on this side. So we're good here. But what we want to find is we want to find what b is. So we can't use this because b is not in there. We could either use the first or the second. Well, I'm always going to stay away from the x squares if that's an option. So in other words, a -x equals 4bx minus x. So let's go ahead and turn that into an equation. A -x from this side equals 4bx minus x. You see what we did? Is we put all the same layers together. So all the x squareds are its own equation. All the x squareds are its own equation. If we wanted, we just don't want to use that one. All the x's are its own equation. And the numbers, if we ever wanted to use it, which I can't imagine why, the negative 40 equals negative 40, well, that's clear. So now we have negative x equals a negative 4bx minus x. We want to know what b is. So we want to see if we can get rid of x. One thing I know here is x is a common factor, so we can actually factor it out. And I don't know if that's a good idea. You know what, we could, but let's see. Let's add x to both sides. And the reason why I want to add x to both sides is because I noticed that if we have a minus x and a plus x here, that's going to give us a 0. That's always a good choice. 0 equals 4bx. Now from what we can do from here is we want b by itself. We don't want 4b and we don't want bx. We want just b. So we want to get rid of the 4 and the x. So we can divide both sides by 4x. That cancels. 0 divided by 4x, well, nothing changes there. That's still 0. So 0 equals b. So what that means when you have b, a 0 for b, because b is the term that's multiplied to your x, is you don't have an x term. So when you go back, what we have is a is a negative 4, b is 0, c is a negative 1. So when we plug that back in, so the equation that we formed at the very beginning, where here's a, here's b, which is 0, so we don't even need to write anything because 0 times x is 0, and c. So we only have an a and a c. So the a is over the x plus 4, so then that is going to be a negative 4 over x plus 4 plus bx, I'm not going to write it because it's 0, b is 0, plus c, c is a negative 1. Always put your negatives in the numerator. It's really confusing to put them in the denominator or out to the side. It's not wrong, but it's really confusing. If you're consistent with your negatives, it really helps to clear things up. So the bx plus c term is the one that had the x squared plus 9. Now when you have plus here and a minus here, you do have the option, it's not a have to, but you do have the option of writing it as a negative 4 over x plus 4 minus 1 over x squared plus 9, because this minus is understood to go to this 1 and not to the denominator. And here's your term. So you have your A, your B, and your C. Now what they want us to do is they want us to integrate it. Now here's what I want you to remember is, in this case they told us to break it down into parts, but I want you to be able to look at this and recognize when you have two factors, you can automatically break it down into parts. You still have to find your A and your BX and your C. If you have a lot of addition or subtraction or something that can be factored, you want to do so. Now we already found our A, B, and C, so there's a much simpler way to write this. We're completely done with this because we have a much better way to write it. We're going to use this. And do keep in mind, this is one fraction here. This is two small fractions. It's always easier to integrate two small fractions over one big one. So to integrate, just write the integral in the dx. If there's any negative signs or constants that you want to pull in front, go for it. So here we can definitely pull out that -4. So that's going to be and -4. So that's just, you just put a 1 there as a placeholder. If you have 1 over x in any form, and that includes 1 over x plus 4, that is a natural log. The integral of 1 over x is natural log of x in the absolute value form. Also, do keep in mind these are indefinite integrals, and you recognize indefinite because there's no numbers here. That means to include a plus c in your answer. This -4, just carry it down, and it multiplies to whatever we're going to get here, which is going to be natural log absolute value of x plus 4. We're going to add a plus c, but we only need to add it once, so I'm just going to remember to do that at the end. As long as this is a 1x, which it is, you can go straight to your natural log. If this were a 2x or anything else other than a 1x, I would probably use substitution. We'd still end up with a natural log, but it would affect this number here.